Hi, in this short series of videos, we are going to set up our development environment and implement very first simple applications so that we act as sort of a template on which we are going to continue to build our agentic systems on. So I decided to move this outside of the main curriculum because I wanted to spend more quality time on actually building out agentic systems rather than setting up our projects within the 8 weeks that we are going to have for this bootcamp. So this, in the future, these videos will also become as a prerequisite for anyone who wants to join the bootcamp. So it will consist of four videos. The first video, which is this one, will be dedicated for actually just simply setting up your development environment. So installing the tools, getting the credentials that we are going to need, and then just testing out that everything works as expected. In the second video, we will be building a very simple front-end application, which will be a very simple chatbot, which will be able to communicate with different LLM models in different providers. In the third video, we are going to move the actual LLM logic, execution logic, generation logic outside from a front-end application, and we are going to deploy it as a separate fast API server. And in the fourth video, we are going to also implement the front-end as a separate application, and all of this will be deployed locally with Docker via Docker Compose. And in the future lessons, which will be the main body of the bootcamp, we are going to take this project and expand on it. So we are mostly going to work in the backend. So the backend application, which is the fast API application, will be worked on most. But in this little short series of videos, we are just implementing the harness of it so that we can expand on it later. So let's start. We are going to mainly code in Python, so we are going to need Python. We will be using UV as our package manager. It's already not new, right? It's, I think, a few years old already, but it is a very fast Python package manager, which is written in Rust, and it simply outperforms any other package manager available out there. And also I will be using Cursor as an IDE. So feel free to choose the tooling that I'm using, but if you're an experienced programmer, you don't need to follow these videos. This is just for someone who is looking to set up their own development environments. So I will be sharing how I do it for my own projects. So so the first thing that you want to have is actually download the Python itself. So you can go to python.org and then you can go to downloads and download the latest available stable version, which is 3.14.2. And I'm not going to download it. I already have it. I have some earlier version, but feel free to download the latest version. And of course, install it. Then for UV, there are multiple ways of how you can actually install this package manager, and all of them are listed here. So I will not be installing it as well because I already have it, but hopefully you will not have or face any issues while actually installing it. So you can if you're running on Mac or Linux, and I'm running on Mac, you can run these commands to get it, and then you can also install UV via pip package manager, or even via brew for Mac OS systems. If you are running some other system, look up for your dedicated commands and run those. For Cursor, you can download it in cursor.com, or you can choose any other IDE that you're used to code. Now we are not going to do any vibe coding, so I'm just using Cursor because I like it. The autocomplete is very nice, but I'm not going to use any agentic capabilities of the IDE itself. So it doesn't really matter much what kind of IDE you're using. Now you will see that in most of the videos that I will usually have my browser open because I will be testing front-end applications as well as my front-end application as well as fast API docs. I also usually have two terminal windows open, one for running Docker Compose, that would be always open here, and another one for installing all kinds of dependencies and setting up my projects. And also, of course, I will have my IDE open, which for me is Cursor, and I'm gonna code here. Now I already have my GitHub repository created, so you can see it's called AI Engineering Bootcamp Prerequisites. It will be a public repository, so once you have these videos available, the repository itself will already also be available publicly, so you can pull it, you can reuse the code, but as always with any other projects that we do here, I recommend and encourage you to code along and actually implement it from scratch. So it will help you learn better and the concepts will stick easier. So I'm gonna go ahead and code it on the main branch for now because it's the initial commit, so I don't have anything in the repository apart from the license, the .gitignore file, and the readme.md, and everything new will be created on top of this. So for now, I'm just gonna go ahead and code straight on the main branch. Okay, so now we have this repository already pulled, and in order to continue to work with it, so I'm gonna use UV as a package manager for managing Python environment. And I'm gonna start doing that right now. So I'm gonna cd into my, first of all, let's go back to home, and then I'm gonna cd to the repository, to the folder where I have pulled the repository. So that will be, in my case, AI Engineering Cohort 3, and I think here, sorry, not Cohort 3. So I'll go back one folder, and here I will have AI Engineering Bootcamp Prerequisites. So cd AI Engineering Prerequisites, and I only have these two files plus the gitignore here. So what I'm going to do now is I am going to initialize a UV project in here. So I will run UV init, and I will choose Python 3.12. For some reason, it just stuck to me, and I will create my virtual environments in Python 3.12. You can choose 3.14 if you want to, but all of the capabilities that I want, all the features that I really want, are available in Python 3.12. So what does this do? This UV init Python 3.12, it creates some files in the folder. So if I would go back here, now I can see 3 new files appear. So the first one is a Python version file, and then some initial hello.py file, which I can delete because I will not be using it. But also it initialized this pyproject.toml file, and right here we'll be adding all kinds of configurations that define the project that we will be running. So first thing, just to make sure that the actual virtual environment appears, let's just add a new library to the mix. So there are a few ways of how you can install new Python libraries to your UV project, but I like using a UV add command. So you can actually install any Python library like this. So what I'm gonna install right now, because I know that I will need that, is ipykernel. So if I do that, a new virtual environment is being created, and you can see, give me 1 second. You can see it appear here, a new virtual environment, and you can also see this package, this library being installed as a dependency in this project. So what virtual, if you're not familiar with Python, or you're not a seasoned programmer or a beginner programmer yet, virtual environment is a local virtualized environment for this Python instance, where the libraries are installed in a separate folder. So I can actually reuse this virtual environment and then later on delete it if I choose to, without installing those libraries in the system Python installation. They're very useful because you can install your local dependencies, local development dependencies here, and each of the projects can have their own. We don't want to necessarily trash other environments with dependencies that are only needed for this specific project. Okay, so this is how you can add dependencies in your UV project, and this is the initial structure of your UV project. We are going to expand it quite a bit in these 4 videos, but for now, let's just start like this. So we have our UV project. The next thing that we want to do is actually test it out and run some code. And we will be running a lot of code in this bootcamp in Jupyter Notebooks, just for test purposes, but then most of the code will eventually be moved into a proper Python code, which we will be deploying in Docker containers. So first of all, let's test if we can run stuff in a notebook. And why I like Cursor is because you can also run Jupyter Notebooks inside of a Cursor IDE. So let's create a new folder. We'll call it Notebooks. And this is where we are going to hold all of the notebooks that we are going to create during this bootcamp. And I'm going to split also notebooks by weeks. And this first video is not really a week, it's a prerequisite video. So I am going to create a new folder, which I will call prerequisites. And here we'll only have a single notebook, and I will call it 01 LLM APIs.ipnb. So this notebook will be created simply to test if we can run LLM calls against 3 different LLM providers, and also initiating the .env file where we are going to store all of our credentials that we need. So let's first of all write some code. Let's mark down some sections. So the first section is where we are going to load the environment. And right here, we are going to use .env library to load environment variables from our .env file. So first of all, let's choose Python for this cell, and from .env import .load.env. This is correct. And then we are also going to import OS and eventually run the load.env command. Now we can see that .env library doesn't exist, and we are going to have to install it. And we can do that. Again, open the terminal, and as previously, just run uv add python.env, I think. Yes, python.env. Once you run this, you will see a new library appear in the list, python.env, and we should be able to import this now because we have installed the library. So we are going to run it, but we do not really have any environment files right now where we are going to store our credentials. So let's create exactly that in the root path of this repository. So right here, let's create a new file. We'll call it .env, and I'll very quickly copy an example. So it's a good practice to have a file called env example in your repositories if you're using .env type of secret storage. In this .env.example file, you usually have a list of all of the environment variables that you require this repository to be set up with, so that anyone who pulls your repo, they know that they need to fill these environment variables in. Then they copy this file and .example, rename it into .env, and then they fill in these secrets. So I'll just copy paste the values into this .env file. And now I know that I need to fill these in order to run the code that is in this repository. Now, what are these environment variables? Clearly, this is the OpenAI API key, which means that we are going to use OpenAI as a provider for some of the models that we will be using in this bootcamp. Also, we are going to use some of the Google's Gemini's model family. And we are also going to use Grok for some fast inference on open source models. So going back to the browser, you can get your OpenAI credentials by simply going to your developer console. Then I already have my organization here, Swirl AI, and I have my own project. So if I would go to my own project and click Manage Projects, I will be able to create a new API key. And I have quite some already here. And for this showcase, I will create a new secret key, which will be called cohort, or maybe it will be just called prerequisites demo. I create the secret key, copy it. So I'll just show you how I do that, and later on I will delete these credentials and use a different set of different ones in my upcoming videos. So just copy your credentials from here, go to your IDE of choice and file, and just paste them here. Now go back to the browser, go Google Gemini console and AI Google Dev. And here you will be dropped into this Google AI for Developers screen, and then you can click on Explore Models in Google AI Studio. And you will have your projects here, and you can create a new API key if you choose to. And I'm going to do exactly that. So create new API key. My API key name can again be prerequisites demo as an example. I select a project, cohort 3, and I create a key. Again, I just copy the key, which is, so where are the names? Prerequisites demo. Okay, so I'm just copying the API key and add it right here. Then I want to also have my Grok API key, and can get that by going to Grok, so grok.com, and start building. And here you will be dropped into Developers Console, and actually you will need to log in first, but I am already logged in. So once you log in, you will see something like this. Then you can go to API keys and create a new API key. So for this, I will just create, again, prerequisites demo, no expiration, submit. I should have my key created soon, and just copy it. Go to the cursor screen, again, copy it here, and you have your credentials ready. So save the files. Again, I will delete these credentials after I record these videos, so don't try to reuse them and steal the credits, because it will not work. Now I can actually go ahead and load these into environment variables. So you do that by importing .env load.env, and then you can load .env. But since we are not running from the same path, we will need to provide a full path to the .env file, and we can just do it right here. So that would be .env. Actually, I think it will be this. So we first need to select the virtual environment, which we want to attach to this notebook so that we are actually executing within this virtual environment. So we do that like just shown, and now we can actually run this. So true means that it succeeded to import the environment variables, and we can check if those have been imported properly by just running os.get env OpenAI API. So we managed to successfully do that. So if you run this kind of code right here, be sure that you do not push anything like this to your GitHub repository so that no secret information is available in your GitHub repository. So what I'm going to do is I'm going to delete this cell right now. And in general, every time before I actually push any notebooks to my GitHub repositories, I clear any output from them. And I'll show later on how to do that so that you do not unexpectedly push any secret values to your GitHub repositories. So now I delete this because I have proven that my .env worked as expected. So since we have those free environment variables, these ones, ready, now we can actually run some API calls against these providers. So the first one is OpenAI. So let's see if we can run against OpenAI's APIs. So let's just mark down and say OpenAI client. And for OpenAI client, I tend to use Chat Completion's Create API. And let me show you quickly how it's done. If you have already worked with LLM APIs, you probably know, but I'm still gonna showcase how it's done. So before we can actually run anything on OpenAI, we need to install some additional dependencies. And I'm gonna go ahead and install 3 of them, so 1 for each of the providers. And the first one would be, actually, I'm gonna go ahead and install all of them in a single line. So UV add OpenAI, then we want Grok, and we want Google GenAI. So all 3 of them should have been installed. Let's double check. Go back to cursor by project. Yeah, so we have Google installed, we have Grok installed, and we do have OpenAI installed. We are going to use these Python libraries to actually call APIs of these providers. That's why we are installing them right now. When it comes to calling OpenAI models, we can very easily import OpenAI. And after importing it, we can get a response from a Chat Completion. No, actually, I'm just gonna go ahead and copy paste what I have, just to save typing time. So this response is generated by calling a Chat Completion's Create API, and this is a more low-level API compared to others that OpenAI has, but it is very well tested. It is stable, and this is what usually you should run in production, unless you really want to rely on advanced OpenAI specific capabilities and you want to kind of lock into their ecosystem. Now, this API is shared by many other providers. So actually other providers tend to be implementing OpenAI compatible APIs. So you can actually use OpenAI's library to run their API calls. Okay, so this specific API call takes in few parameters. There are more, but for this simple example, we are just going to use few. First, you define the model. So in this bootcamp, we are jumping to GPT-5 instead of using GPT-4. And the GPT-5 has multiple families. It has Nano, Mini, and GPT-5 regular. So we are going to use, for now at least, the cheapest version, which is Nano. This is actually almost 3 times cheaper compared to GPT-4o Mini. However, it does some reasoning under the hood, and those reasoning tokens are also charged, so they do cost. Now, let's see. Let's try and run this, and I think this one will actually run for quite some time. I think 7 seconds or more. But in general, we are providing 2 messages. So the first one with the role system, and the content is your helpful assistant. So basically, this is a system prompt per se. And the next message is user message with a content. Can you print 10 random words? So you could imagine this being a chatbot, which has a very simple system prompt under the hood. And this is what our user asks the model. So if we run this, it should work, hopefully, and it will run for around 7 seconds, I think. Yeah, and it produced 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 words as we have asked it to do. Now, interestingly, it took quite some time, 7.2 seconds, even though the GPT-5 Nano is kind of the fastest model in the family. Now, this happened because of the reasoning tokens. So if you would go ahead and run response usage, you can see some metadata about it. So in total, we had 334 completion tokens, which is quite a lot, because usually there's you could estimate around to have 1 word to have around 1.5 tokens. So that means 10 words. This should be around 15 tokens, not more, and we have 534 tokens in total, completion tokens, which is a lot. Now, why do we have that? We have that because we have 512 reasoning tokens. So that means that there is some reasoning happening under the hood. We are not exposed to it, but we are still gonna be charged for these reasoning tokens. So charged for them, and they also incurred quite a lot of latency. 7.2 seconds to generate 10 words is quite a lot. So yeah, so prompt tokens 24, so 534. As expected, 534 in total completion tokens, 512 in reasoning tokens, so 534 minus 512 is 22. So that's 22 tokens right here. A bit more than expected, but still reasonably low. So can we improve this? Yes, the answer is yes. And this is a new thing in the API, which is only available with GPT-5 family of models. But if I would copy this and also set reasoning effort, so reasoning effort, if I would set it to minimal and run it again, I think it should be really fast. Yeah, so 1.9 seconds to get 10 words, which is a lot better than the 7.2 seconds. And let's see how many tokens do we generate this time around. Running a response usage, you will see that in total we have only 59 completion tokens and 24 prompt tokens, total 83. So this is all 59 tokens are here. So we don't have any other tokens because the split can also be seen here. We don't have any reasoning tokens. We only have completion tokens. So there was no reasoning under the hood because we set this to minimal. Now, if we would try and set this to, for example, low, because we can have minimal and low, and the medium and the high, it will run for a little bit longer. And now we can see that those numbering has been removed, etc. But now we have some reasoning tokens, which is 128. Now, for most tasks, we do not really need reasoning tokens, so we'll almost always stick to having minimal reasoning effort. So anyway, since I wanted to jump from GPT 4.0, which we used to use in previous bootcamp cohorts, to GPT-5 Nano and other families, I wanted to introduce this reasoning effort parameter, which we will be tuning a bit during this specific cohort. Okay, now we have just shown that we are able to run OpenAI client. Now let's try and run Google client. So let's mark it down. Google GenAI client. And let's add some code blocks, and I'll just copy paste what I have to save typing time. And right here, we will be importing from Google, import GenAI, and the client is initiated like this, GenAI.client, and then we're providing API key like this. So this is taken from our environment variables, and response in this case is under the API models.generate content. We provide a model that we want to use. We are using Gemini 2.5 Flash because it is available in the free tier. And if you would try and use it with 2.0 Flash, you will not be able to do that anymore because we removed 2.0 from the free tier. So 2.5 Flash is what we are going to use for now, at least. And instead of these messages, what Google's API takes in is contents, and contents is a list of multiple things. And in this case, we are just stitching up two messages together and basically providing first the system prompt and then the user prompt without specifically saying that. Let's run it and let's see if it succeeds. Yeah, so it works. Now we asked for 15 words. 2.8 seconds, which is quite nice. I think it's comparable to 1.9 because this one only had 10 words. So this is still quite nice. So Google GenAI client works. Now the next one, let's look into the Grok client. So mark it down, Grok client right here. And again, copy paste what I have to save typing time. So from Grok, import Grok. The client initiates very similar to how you would do that with Google's GenAI client. And the API is very similar to OpenAI's API. Actually, the same client chat completions create, even though the client is initiated from the Grok's class. We communicate via this client with the LLM in the same way you would do that with OpenAI API. So we provide a list of messages, again, system and user. And in this case, we are asking for 20 random words. Now, if we would go to the Grok's console, and we didn't spend much time on looking into what Grok is, but basically Grok provides multiple open source models through their platform. And you can access things like Llama models or GPT open source models and some additional models as well, like Qwen and similar. Now, no one really likes Llama 4, so we are gonna stick to Llama 3. And in most cases, that would be Llama 3.3 70 billion versatile. And this is exactly what we have in this little piece of code right here. We are choosing this model, Llama 3.3 70 billion versatile. And we are gonna go ahead and try and run these messages against this specific model in Grok's API. And it's super fast, 0.6 seconds. And that's what, by the way, Grok is famous for. It is famous for extremely fast, lightning fast inference speeds. And that's what we see here, 0.6 seconds for 20 words generated compared to, in this case, 2.8 seconds for 15 by Google. and 1.9 seconds for 10 words generated by OpenAI. And this GPT-5 Nano is kind of the fastest model we have. Now, it's not comparable. It's not like comparing apples to apples, because 70 billion model is not that big. It's not that big compared to what OpenAI is and Google's Gemini models are. Probably they have potentially trillions of parameters. So we have just shown that we can actually run code against LLM APIs from different providers using our .env file and the notebook. And this is actually what I wanted to do for the first video. In the next video, we are expanding this case and we are implementing a front-end application where we can actually chat via chat interface. But to end this video, just wanted to also add a few words why these providers. So OpenAI is obvious. They are the most popular. We have many models that we might want to test and figure out how to use. Plus, we will be using their embedding models a lot for our RAG applications. When it comes to Google Gemini models, mainly I use these models for data extraction from PDFs. And we are going to also use that in this bootcamp. And for Grok, I just wanted to have a provider which is not a proprietary model provider. I wanted to have a provider which provides open source models. So Grok is quite an obvious choice. I also wanted to have a provider which has blazing fast inference speeds. So we'll be using Grok for that. So this concludes the first video. In the next video, we are going to implement a very simple Streamlit application, which will expose a front-end UI with a chat interface. And we are also gonna introduce some Docker into the mix and Docker Compose files to run those applications locally. So all of that will happen in the next video. I'm closing this one and hope to see you there. Cheers.